Hi, welcome to join our webinar. This is Joy from SW China, Hong Kong, and I'm the MC today. Our topic today is about GIS BIM integration on town planning, and we will have 4 speakers with us. They are Nora, Kelly, Daniel, and Calvin. Before we begin, please plug in your earphone for the best audio performance. You will be in listen-only mode. You can either join with computer audio if you're using Zoom web browser. If you're using mobile device, please join with internet audio. We will have Q&A section at the end. Please feel free to type your question or comment in the chat box anytime during the presentation, and we will go through them during the Q&A. Before we start, I would like to call for your action to register for SW User Conference, which will be held from 12 to 15 of July. Pre-registration is required. Everyone, even without an Arcgis account, can register to watch the plenary session for free. Rewatch is also available afterwards for registered participants. For our customers under the maintenance program, you will get full access to the event, including plenary session, technical workshops, and hundreds of hours of training sessions to learn about the latest GIS technology development. Please register as soon as you can. Our webinar today will be divided into 3 parts. First part will be introductional speakers. Then our speakers will present the topic on GIS BIM integration on town planning using our web app available on Arcgis Online called Story Map. Field demonstrations will be shown, which included GIS BIM integration and some analysis on surface area, network, wheel shed, ventilation, noise level, and much more. So here comes our first polling question. Are you using any GIS or BIM technology platforms? Maybe we can have 10 seconds for you to answer this question. Okay, so now let's see the result. Most of you answer I use GIS. Wow. So let's go for another second polling question. How would you evaluate your competence level in using Arcgis? We have several choices: no knowledge, beginner, intermediate, or advanced. Let's have another 10 seconds. Okay, so most of you answered beginner. Maybe you will learn something new from this webinar, and I hope you enjoy the rest. Okay, let's welcome our 4 speakers. They are Kelly, Nora, Daniel, and Calvin. They are all studying urban studies at the University of Hong Kong, and they work as a group for the project Energizing To Kwa Wan Renewal Project. Kelly's work mainly revolves around application of urban planning and design theories, as well as other applied learning, such as GIS application, data compilation, and spatial analysis. Nora's work focuses on urban citizenship, sustainability, and smart city development. She currently serves the Center of Civil Society and Governance as a student research assistant, where she takes part in projects like rural sustainability and partnership for sustainability leadership in business. Daniel is preparing himself to serve the field of urban planning and design. He specializes in concepts of city planning and design, as well as GIS, spatial data, and digital modeling knowledge. Currently, he is an intern at the URA Urban Renewal Authority, contributing for better urban living in Hong Kong. Daniel is one of the winners of our SW Young Scholar Award this year. Lastly, Calvin specializes in town planning and GIS. He has served in multiple transnational operations, including SW China Hong Kong, as an intern, and contributed to various consultancy studies related to smart city, CSDI, and spatial data in building a smarter Hong Kong. May I now pass the time to the team? The floor are yours. Thank you.
Good evening, ladies and gentlemen. We are a group of HKU students working on an urban renewal project in To Kwa Wan. Today, we would like to talk about how we apply BIM and CIM technologies in the process of formulating a redevelopment plan. Let's start by introducing our team members. We have Calvin, Daniel, Kelly, and myself, Nora. We are all undergraduate students taking urban studies at the University of Hong Kong. So our subject site is situated at junction of Wing Kong Street and Tai Ming Street. It comprises 2 adjoining development project sites of the Urban Renewal Authority. With a total site area of 3,007 square meters, the site also includes a portion of the surrounding public pavement. So our presentation today will be divided into mainly 5 parts. First, we will introduce the site condition and give an overview of the site conditions. After that, we will go through design considerations that have been taken into account before we propose a scheme. Last but not least, we'll present results of CIM analysis that evaluate the potential impacts of the proposed building and the surroundings. We will also be demonstrating some Arcgis Pro functions in detail from time to time, so don't miss out. To begin with, I will give an overview of the existing conditions around the site. So To Kwa Wan is predominantly a mix of residential and commercial areas where a mass of cheap housing and light industries can be found. It is now a strategic area for urban development led by the URA. Let's take a look at these pictures which show the urban problems of our site. What can you see? So first, the buildings were built 60 years ago. They are rather short with either 6 or 8 stories. They are mostly residential with commercial premises on the ground floor. Also, the buildings are dilapidated due to poor building standards in the past. Moreover, the exterior facade has worn out while the interior environment is crowded and unsatisfactory. So a large-scale redevelopment is needed to improve the neighborhood's living conditions. After the relocation of residents and tenants, there is an abandoned alley between the buildings in the site. It is deteriorating without any maintenance work being carried out. In addition, we observe casual parking along the streets, mainly due to the presence of maintenance garages and insufficient car parking services in the neighborhood. So after that, we have utilized Arcgis Pro to conduct the baseline study. First of all, according to the outline zoning plans, our subject site is zoned Residential Group A. Open space and GIC facilities can be found over the district, while retail facilities are sparsely distributed. Since To Kwa Wan is a densely populated area, more retail complexes shall be built to support resident shopping needs. Next, we have analyzed the role hierarchy of To Kwa Wan according to the road functions and capabilities. First, the East Kowloon Corridor is the major motorway for high-speed traffic over long distances. And the Ma Tau Rai Road is the major public transport route. In particular, our project site lies on a secondary road. It is quite accessible because it is located adjacent to the main road, Ma Tau Rai Road. And last but not least, tertiary roads in the surroundings area handle lower volumes of localized traffic. So next, we have Kelly to talk about connectivity of To Kwa Wan and the accessibility of our site.
Thank you, Nora. In this part, I'll talk about the spatial analysis done by GIS. First, the methodology for data collection. A lot of our data, such as public amenities and auxiliary facilities locations, were taken from Google Map as well as GeoInfo Map. It is a pretty good tool, although not the most efficient, but it gets the job done in terms of understanding the surrounding environment. And from the data collected, we were able to conduct an in-depth analysis on the surrounding. We used a surface area analysis to identify the public transportation services in the site, which tells us about the accessibility. Here we see a surface area analysis of the nearby MTR stations, the existing ones as well as the ones that will be open to traffic by the end of the month. An analysis of the distance from the MTR stations were done. We have taken the distance of 100 meters to 700 meters away from the MTR stations. We also did another kind of analysis, which is the network analysis, showing the walking distance from the MTR stations as well as the best route to walk from it. For the bus stops, since there are a plethora of stops nearby, it would be inefficient to conduct a surface area analysis from each stop. So we opted for a buffer analysis. By placing a 1 kilometer radius buffer, we were able to see the number of stops fallen within the vicinity of the site. Since distance might be confusing to some, hence in addition to it, we did another kind of surface area analysis, which is using the walking time from the site. We can see that this is a 0 to 5 minute walk, a 5 to 10 minute walk, as well as a 10 to 15 minute walk. So within it, we could see that there are a number of bus stops we are able to access within at least a 5 to 10 minute walk. So we have prepared a demonstration on the surface area analysis. So before we could begin with any kind of analysis, you have to create the point for you to do your analysis on. So how could we do that is on your right, under the database, right click and create a new feature class. Afterwards, give your feature class a name. What would the name be? In our case are the MTR stations. Afterwards, choose your feature class type, which is a point for us, and you could create a new row of field, which is a name for your points. Since there are more than one point within this feature class, it will be easier for us to identify them. So after you have created, there you see the feature class under the database. You could just drag the created feature class into the map. Nothing will show up yet since the feature class is empty. So what you could do next is to create your feature point in the edit toolbar. So you could just create the 2 points, which are in our case are the existing MTR stations. Well, after you have created them, just press save. There you have the 2 points, but it is a bit small for everyone to look at. Therefore, under the symbology, we'll change the symbol to something easier for everyone to identify. And afterwards, you could go to the attribute table and just edit the name for each point. So this will be the Halmentine station, and you could just change the selection, click onto the other MTR stations, and just type in the name for that station and click apply, and that's how you create the 2 existing MTR station points. As for the new MTR stations, you just repeat all the steps again. As you can see, we have already created the 2 points, but again, the symbols are too small, so we'll change the symbols. But since they are both MTR stations, the icons are the same, so we'll go to properties and just change the color into something easier for everyone to differentiate, and click apply, and that's how you will have created the 4 feature class or feature points for you to do your analysis on. Again, like the previous step, you could just change the selection, click onto the station or click onto the location you like, and under the attributes you could just change the name into something easier for everyone to identify. And that's how you will have your basis for the coming analysis. So next, moving on, after you have created all 4 of these points, what are you going to do is your analysis. So you could go to analysis on the toolbar and click onto network analysis and select a surface area analysis, and that's how you will have the rows on your left under the contents. Afterwards, you could just select your mode of analyze. In our case, are the walking distance. So walking distance are in the unit of kilometers. So we chose the walking distance will be 100 to 700 meters away from the facilities of our choice. So you just input the cutoffs into this table, travel settings. Afterwards, import your facilities where you will be walking away from. So in this case are our MTR stations. So you could just input locations as MTR stations and run the program. And that's how you'll have this result of a distance away from the MTR stations. Since the color is in purple, we have changed under symbology again into something easier to read. So you could just do the same for new MTR stations, and on your left under the content, you could just change it into something easier to read, not the 0.1 or 0.7 kilometers, but more or less 100 meters to 700 meters. Again, you could just do the same for the new NTR stations, which we have done prior to this webinar, and that is how you do a surface area analysis. Now we will be talking about another kind of analysis, is the walking distance. Similarly, we have our 4-point basis right here. So what we'll do this time, under the analysis toolbar, network analysis, similarly, we are doing a surface area analysis. As you can see again on your left, columns will be popped up here. However, this time, instead of choosing NTR stations, we'll be choosing a walking distance away from our site. So how to do that is to create your facility. Instead of inputting it, create your own facility, which is starting from our site right here. After you've created it, you could just press save, and you have created a facility right there. Go back to surface area analysis, but this time choose it as walking time. So how long you wanted to walk away from our facility, which is our site. So after you have input the location as our facility that we have chosen right here, you can just press run the program, and that is how you will get the end result of a walking time away from our site, with cutoffs of 5, 10, and 15 minutes. Again, for the time being, we have already edited the color and the name for easy reading. Darkest color for walking time of 5 minutes to 10 minutes up to 15 minutes. At last, we will have a demonstration on how to create a walking route. And for our walking route, we are starting again with the same 4 dots for locations we have inputted. However, this time, instead of a surface area analysis, we'll be doing a route analysis, which is also under network analysis. After you have pressed route, you'll see this on your left. This time we'll be doing a walking time. Like the 2 previous demonstrations, you have to input your locations, which points you will be having your analysis on. However, this time for our route analysis, instead of your usual locations, we'll be creating these kind of stops. And what the stops mean is the starting point and the ending destination of your route. So you have to create 2 points here, and then you could go back to inputting your locations and press run the program, and you'll get this kind of you show a line to identify, to show you how you can walk from your first location to your second location. In our case, are the MTR exits towards our site. So for the time being, we have already conducted all 4 routes from each MTR stations to our site. And when you click onto the route, which will not only show you the time required to walk from your stations to your site, it will also show you the distance that you will need to travel. We also did analysis of other utilities to understand the degree of establishment of the site. Here we have a shopping mall analysis. We see that there are several shopping malls in the neighborhood, but are located rather distant from the site, hence showing perhaps a need for the establishment of bigger shopping malls. Other important public utilities such as police stations, fire stations, and hospitals were done. Our site is very accessible in case of emergencies, as we can see from our analysis, especially in terms of driving time from fire stations and hospitals. We have identified from our spatial analysis that despite our site is located in a rather old district, it still fulfills the requirement of the Hong Kong Planning Standard and Guidelines and could reach our site rather quickly. We also analyze parks and wet markets. The provision and availability of them is very important to understand if it will be able to support and satisfy the new development project. We can see here that there are 2 large wet markets within at least a 10-minute walk from our site. And understanding the accessibility is especially important for parks, since in the Hong Kong Planning Standard and Guidelines suggested that local open spaces should be within walking distance from residents. Therefore, from conducting a spatial analysis, we were able to identify that this location is preferable for residential development, as at least 2 of the parks fall within a 400-meter radius buffer of the site. Another consideration we have taken is the walking time to school. Therefore, in the network analysis, we analyze the walking time to schools. From the Hong Kong 2030 plus framework of accessibility, it is preferable that if there are educational facilities available within 500 meters from home to create a sustainable Hong Kong. And from our site, various educational facilities are located within a 500-meter radius. Hence, our development site is ideal for families as well as maintaining a low carbon and sustainable lifestyle. Now I'll pass the time back to Nora.
Thank you, Kelly. We also generated a heat map to analyze the pedestrian flow around the site. To assess pedestrian flow, we recorded 100 data points in different road junctions during site visits. A scale of 1 to 10 was used to measure the density, with level 10 being the most densely populated and level 1 being the least densely populated. The result shows that Kowloon City is generally a high-dense area, with most data points reaching level 6 in terms of pedestrian density. On the other hand, areas like Hong Kong, Whampoa, and Kowloon Hospital are particularly more crowded due to the presence of large-scale commercial and healthcare facilities. So here's a step-by-step guidance on how to generate a heat map using Arcgis Pro. First, open a new Excel sheet. Input all the necessary data into the sheet. For our case, we use pedestrian density level. As I've mentioned, a scale of 1 to 10 was used, and there are a total of 104 data points. After you finish, save the file as an Excel workbook. Then minimize the Excel window and proceed to Arcgis Pro. Select the View tab on the main toolbar menu and click on Catalog pane. To start creating a point feature class of all the data points, go to the Catalog pane, select the designated geodatabase, then right-click it, New, and Feature Class. Input a name for the feature class. Then select Point under the feature class type and click Next at the bottom. Here we can add a new field. Rename the new field according to the feature class name. Then select long integer under the data type and click Finish. After loading, you'll be able to find the created feature class in the geodatabase. So add it to the map. Then under the Content view, highlight the pedestrian level feature class and go to the Edit tab. Use the Create tool to create the points or locations. Under the Create Features tab, use the Create Points tool and draw a point on the locations indicated in the figure. After so, save the creation of points. Under the Content view, right-click the pedestrian level layer and click on Attribute Table. Input all the pedestrian level data according to the Excel sheet. So this is a view after all the data points are added to the map. After you finish, save the creation of points. Then you may check the values of pedestrian density by clicking on the dots created on the map. After that, under the Content view, right-click the pedestrian level layer and click on Symbology. Choose Heat Map as the primary symbology. Then you can select pedestrian level as the weight field. Then choose a suitable color scheme. And select Dynamic as the method. You may also adjust to the best rendering quality. And adjust the radius to see which radius gives the best visualization, say 40. And after that, you may format the color scheme. This can be done by adjusting the transparency of the continuous color scheme, say 50%, such that the heat map is visualized appealingly and accurately. Click OK when you're finished, and that's all.
Thank you, Nora. Apart from analyzing the spatial and geographical characteristics of the site, there are several aspects that are crucial for consideration before developing the design scheme. So in terms of the physical constraints, the site parameters determine the foundation and boundaries of the development, such as gross floor area, site area, perimeter plot ratio, and also the building height. Besides, we took a look at some plans and proposals to understand the possible future changes and how society views the potential of the area. So for instance, there is a urban renewal plan for Kowloon City prepared by the Kowloon City District DURF. As you can see, our site actually within the proposed redevelopment priority area, and it's also the To Kwa Wan Central Strategic Area. This tells us that our site should focus not only in residential benefits, but also the overall character of the district as well as the social and cultural needs of the community. And to summarize our preliminary findings, we did a SWOT analysis to give a general overview of the situation. So after using GIS technologies and techniques for conducting spatial analysis, we came up with a conceptual design scheme as a redevelopment proposal. The trio, our name of the development scheme, used BIM technology to create a 3D building model that fits both site parameters, as you can see here, and also our aims for the project. The magic of BIM lies within the power of integrating technical building information or structural prerequisites and aesthetic graphics into one professional platform. BIM is able to build technical 3D models and generate building plans at this one, elevations, and sections for thorough explanation and understanding towards the concept. For instance, the elevation shows the exterior of the building, while the section below here illustrates the programs or activities that are scheduled or arranged in the trio. And this is one concept simulation of our project. Moreover, rendering engines are perfectly compatible with BIM, which elevates project visualization to a more realistic approach. So as we navigate through, we can see how our design can be demonstrated with aesthetic renderings. For instance, the at-grade open space here, the vehicular access, the podium garden for leisure and outdoor relaxation, the light well, building orientation, and more. So, the conceptual flat design is also available from below, showing the flat mix and the residential tower. So before conducting the CIM analysis, there is one crucial step. So let's go through the steps of BIM-GIS integration by watching these two videos below. So first, let's go through how to import a IB 1:1000 digital map into the Arcgis Pro. So first, let's go to hkmapservice.gov.hk and select the Open Data Geospatial tab. As you can see, we go to a panel and select Spatial Data and Topographic Map, and to select the corresponding sheet tiles and numbers. So we used just 2 tiles here for reference and illustrational purpose. And as you can see, the sheet tiles can now be indicated clearly in the map. So to download these 2 maps or these 2 specific tiles, you need to go to View first, and then select the product format, which is FGDB for us for the Arcgis environment, and add it to the download queue. And same for the next one. Just select the correct format and add to the download queue. And then we go back to the home page and to select these data from our download queue and to export them accordingly. We need to extract them to a folder before going to the Arcgis Pro to import them. Okay, so first let's open a new project, a local scene or a global scene is fine. So I select the local scene here. To import these data, we need to first connect the databases in order to import them here. So just right click and to connect them, and then as you can see now, we can have the access towards the data in the folder. And just very intuitive design, we just drag and drop, and then the data will be imported into the Arcgis Pro. And same for the next one. Let's go to the geodatabase and select the according building shapes. Drag and drop, and there they are. Then we need to do some adjustments by going to the Appearance tab, the type, and there should be an absolute height for you to select. And then for the field, let's use the roof level, and then to generate a 3D model of the district or the community. And as you can see, just a few seconds, the 3D models will be generated. And this is how you can do a 3D modeling of the building blocks surrounding your site. And after doing so, we can move on to the next step, which is to import the building into Arcgis Pro. Okay, so after that will be the tutorial on how to import our building model from BIM into the GIS environment. Okay, so next up, we'll go through how could we perform the BIM and GIS integration by importing the BIM model into the GIS environment. So before in doing so, we need some preparation work. As you can see here, there are some existing building blocks. So we need to get rid of them. And to do so, we could go to the Edit tab and go to the Select tool. Using different select options, we can choose the appropriate building blocks. And after doing so, we can simply go to Delete to clear the site. And don't forget to save all our edits before going to the next step. And the next step would be the importation. So let's go to the folders after connecting them, of course, and to simply drag and drop the data into the GIS environment. So don't forget to checking all different aspects and different levels and layers to fully render the model, but it takes time. So let's do some georeferencing work. So as you can see there, under georeference tab, go to Move to Display, use the button to generate the model near our site. But what if we need some final adjustments? We can simply use the Move tool here and to just drag our model manually for a better precision and for a more accurate location. As you can see now, our model is in position. So actually there are other tools as well, such as the rotate tool and also the scale tool, but we are not going to use them today. And remember, so we need to save all our edits before closing the georeference tool. After that, we need to give Arcgis Pro at some time, since it is rendering the whole building. Every facade, every wall, every components will be rendered accordingly. So after a few minutes or a few seconds, the model will be rendered completely, as you can see here. And this is how we can import the whole BIM model into the ArcGIS environment and to set up a digital foundation for the Cim analysis. As you can see here, everything will be in 3D. So we will now pass the time to Kelvin to continue on the Cim analysis.
So thank you, Daniel. So here comes the last part of our analysis, which is the CIM analysis. So CIM stands for City Information Modeling, which combines the technology of GIS and BIM together. So by injecting the BIM model which we created in Revit, we can simply implementing into the GIS software and conduct multiple analysis to find out and actually understand the potentials and also the threats of our site that actually affect the values of the flat we are selling. So for the CIM analysis, we have come up with 4 different types of analysis for demonstration today. So we have building height analysis, we have strata analysis, feature analysis, as well as the noise level analysis. So first of all is the building height analysis. So as you may see from the graph, we have actually categorized the buildings from all of the Kowloon into different categories according to their building height. So the major objective of this analysis is to find out that the potential views of our flats, whether it will be blocked by the surrounding buildings because of the tall buildings around. So after we conduct the analysis, as we slide down into the next graph, you can actually see that most of the buildings around our site is actually below 40 meters and 20 meters. So it's actually quite low, and that the views of our site are being guaranteed for almost for the next 5 to 10 years, despite of their being demolished or renewal, etc. So the next analysis we have conducted is the noise level analysis, and it was one of the most vital analysis because it is actually affecting the value of different flats in our site because of the noise pollution level. So to access the noise level, we have actually collected noise data points according to our site visits. So after our site visits, we have input all of our data points into an Excel file like what we have done in creating the heat map for pedestrian density. So after we input all our data on sequence, we input the data points into the GIS software, and here's the final result. So different data points have been categorized according to their noise level in the units of dB. So as you scroll down the story map, you may see more points are being eliminated, and finally the west side of the site, you may notice that most of the points are being larger than 90 dB, which the noise pollutions are being the most intensified. So it was one of the major reasons because of the proximity to the major primary roads and highways next to the site on the west side, while as you may notice on the east side, most of the noise polluted points are actually being eliminated, which stands that there's a low level of noise pollution. So in the combinations of hotspot analysis as well as the cracking model analysis, which will be demonstrated in the following video, it's actually generated the noise level intensity map, as you may see from the graph here. So the green and blue colors represent the cold spots of noise level, which stands for the low noise level and noise pollution. While for the west of the site, we may notice a lot of red, orange, and yellow area, which stands that it has a lot of hot spots, and the hot spot represents a high level of noise pollution, which may actually devalue some of the flats on the west side as well as from the north side. So as you may notice that this analysis is actually quite useful, especially when we would like to value a flat or a building or a mall using the impact of noise level. So how we can do this? So this video will help us to find out. So first of all, like what we have done in the creations for the heat map of pedestrian level. So we have input all of our data points in sequences according to what we have done in the field visits. So we save all the data points file, and we create a new feature class in the GIS software, which is a points feature class, and we call it as noise level data. So later on, we use this feature class to import all the data from the Excel file. So after we created the points feature layer, we click next, and we add the field called dB. So dB stands for a unit for sound. So we later on put in the integer data into the field. So we put in the data type as long integer. So we continue to click next, and we make sure that the coordinate system of this feature class is same as the map as WGS 1984. And we finish creating the feature class as once it has been completely loaded. All right. So yep. So it's running. Okay. So after we input the feature class, we drag the noise level data feature layer from the right catalog side into the map directly. So similarly to the previous steps as Nora has just demonstrated, we use the edit tool provided in the toolbar, and we click create and click the noise level data, click the arrow, and start putting our points into the map. So of course, one thing to bear in mind is that the data points, it should be doctored as according to the sequence you have created in Excel file. So for example, the first point you created is corresponding to the A1 data points as we have just shown in Excel file. So for the demonstration purposes, we have created 9 data points here. And we click save and finished. And after that, we open the attribute table and input all of the noise level data into the data points one by one as according to the Excel file we created. So for the demonstration purposes, we of course not going to show you how we input the 100 data points we have been actually doing for this project. So as for the time being, we have actually created another layer of feature class, which is known as the noise larger than 60 dB as you may see on the left side of the content page, which is the second layer here. Alright, so we will now unclick the noise level data we just created and take the noise larger than 60 dB file. So here is this, there's over 100 data points here, which has actually recorded the actual noise level we have been collected in our field visits. So after we've input all of the data points, we can start doing our analysis. So we click the analysis toolbar on the top of the GIS software. We click Geostatistical Visit and select the empirical cracking model. So make sure that we will select the correct data set, which is the noise larger than 60 dB data set. So we will not mess up with the setting here because we are not mathematicians. So we just click next, and the system will actually calculate the intensity map for us automatically. So now, as we want to click finished, this intensity map will be generated automatically in GIS map screen. So we track the empirical cracking model results to the 2D layers, and we have a better visualization. You right-click the layer and click symbologies, and we can actually change, for example, the color scheme to the intervals layers. So what is the interval layers? As you may notice that it is actually class breaks, or what we simply call the categories of noise level, which the system generates automatically. So for instance, from the 60 dB to 90 dB data points, it has actually created a 10 classes interval for us, which, for example, the first interval is regarding the 60 to 61.1 dB, and as accordingly. So here is it. So if you want to create a precise model, that you may choose more classes and so on and so forth. So at the end of the day, we also switch our transparency of the color so that we can overlay the intensity map to the map to have a better visualization. So that's how we created the noise intensity map with the empirical cracking model using the geostatistical visit. So after the noise analysis tutorial, we've come to the third part of the analysis, which is the shadow analysis. So shadow is another critical factor in affecting the light penetration between buildings. So the major objective of these simulations is to find out that whether once the completion of our site will actually affect these sunlight penetrations towards the surrounding tall buildings. So as you may see from the simulations, there's no significant impact from our site of being creating a serious light blockage to the surrounding tall buildings, which it gives a high potential of our site because it will create certainly a higher social acceptability to the residents nearby. So the last part of the analysis is also another very critical part, which is the future analysis, which is also actually affecting the value of different flats in our residential block. So in the future analysis, we have actually created different vantage points to see the POV view as in first person to actually know the visible ranges and the non-visible area from different flats. So the yellow area here shows visible, and the blue area shows which of the parts is invisible. So here comes the last part of the tutorial, which is the future analysis tutorial. So to conduct the future analysis tutorial, so we will pick one of the self-placing flats in mid-level of our residential block for the demonstration purposes today. So as you may scroll down from the GIS software, we can hardly and barely assimilate the view because we can hardly zoom in to the actual balcony of the flat we want to see today. So GIS actually helps us by their interactive analysis too. So under the interactive analysis, there are different tools you may see, such as the view dome line of sight. But for this tutorial, we choose future analysis, which will actually show a circle of radius and actually shows the visible and non-visible range, as you may see from the story map just now. So one of the most critical parts for the future analysis is, of course, the settings and parameters that need to be set. So first of all, on the top side of the top parameters we set is, of course, the heading. So for this tutorial, we are choosing a south-facing flat. So we will, of course, choose the heading of 180 because, as you may learn, that for the polar coordinate of south is 180. And for tilt, we simulate a head movement that we look down the balcony. So we choose -1 as for our data input. And for the horizontal angles, we will pick and put in 360. So at the end of the analysis results, we will have a comprehensive and all-rounded views of whether which part is visible and not visible at all from the flats we would like to analyze. And finally, for the future distance, we will pick 2,000 meters as maximum, so that the system will help us to analyze the radius up to 2,000 meters, as you may see here. So for the results, the red area shows the visible part, and the blue area shows the non-visible part. So for these flats, a lot of sea in the Kowloon Bay and also the rooftops of a lot of Hong Kong buildings are being shown and be visible when you simulate as being the residents of these flats. So what if we put the vantage point to the most bottom flat of the south-facing side? So as you may see, that most of the sea view are being blocked by the Hong Kong buildings, and the red area are being very limited due to the blockage by the surrounding Hong Kong tall buildings. So this is actually the power of the interactive analysis to actually help us to simulate whether which of the flats are being more enjoying more sea view or enjoyable views by the residents without being physically constructed and also being physically visiting. So we can also pick and change the color scheme of the visible and non-visible area as well by the properties menu. So that's all for the future analysis tutorial, and comes to our last part, which is the wrap up and conclusion. So here's the actual visualizations of the last part, which is the before and after redevelopment graphics. So before the development, we can see a large town building situated here, and after the development, there's a beautiful trio is completed and being constructed here. So thanks to the technology of BIM and GIS respectively. So of course, we have identified a lot of potentials and also threats to our site using the analysis tools inside GIS, but that's not the end of our presentations, because we have one more thing to show, which we created a website that used it to introduce the trio to the potential buyers of our flat and potential tenants for our mall. So using the combinations of technology of GIS as well as the other programming languages, including but not limited to Python, JavaScript, as well as the power of Arcgis Pro, Arcgis Online, and Revit, etc. So by using the combinations of Python and also the JavaScript and Node.js, etc., so we've come up with this programming script for our website, as well as some of the most important elements to actually support our websites, including web scene ID and so on and so forth. So finally, we come up with the website here, and which is the introducing trio to everyone. So first of all, once we approach the website, we can see that there's a lot of different tabs on the right side of the catalog. So when we press, for example, Kowloon City here, the website will actually help us to directly identify the Kowloon City view of Hong Kong. So once we, for example, we click site location, we can actually zoom in to have a better look of our site locations, and we can actually zoom in by our mouse cursor, so on and so forth. So for example, if I'm a potential buyer for one of the flat A of our residential block, and would like to see the view of the high level flat, so we will click flat A view bracket high here. So the website will automatically direct us to the flat A balcony site. So we can see that, oh, there's a enjoyable, wonderful sea view here. So we can actually identify it by using the combination of GIS and also the website technology. For example, we want to see the view from a low level flat C site. So it will also direct us to the balcony of flat C here. And we can also find out that, oh, most of the views are being blocked by the buildings in Kowloon cities, and that we cannot see the mountains or the ridge line very beautifully. So that's the website that we would like to showcase. So we click surroundings, and we actually see how the building is situated in the skylines of Kowloon City as well. So that's all for the demonstration of our website as well as our presentation as well. So a big kudos and bravo to my team because they have also invested a lot of time and hard work here. So thank you very much for your listening as well, and we enjoy it as well, and we welcome any questions. So thank you very much.
So thank you, Kelly, Nora, Daniel, and Kelvin for your presentation. So for all our audience, if you wish to review the story map again, please scan the QR code. And we will have 2 more polling questions before we enter our Q&A section. Please take this chance to type your question or comments in the chat box. So here comes our third polling question. Which of the following topic covered in this webinar interests you the most? So let's have 10 seconds. We have spatial analysis using GIS, building 3D modeling using BIM, BIM-GIS integration, CIM for impact assessment and simulation. Okay, let's see the answer. Okay, we got it. So most of you answered BIM-GIS integration, which is great. That's the theme of our webinar today. So let's have our next polling question. How would you think about this webinar? I think our speakers would like to know. So let's have 10 seconds to answer this question. Okay. So 2 more seconds. Okay, I got it. Most of you say, actually, most of you answer just great, and some of you answer, I learned more about BIM-GIS integration. We are pleased to know about this result. So now is the time for Q&A section. Let's see if we got any questions from the chat box. Actually, I find some of the questions in the chat box and I've typed into the PowerPoint already. Let's go for it. So for the first question we got from the chat box is, do you think integration of GIS and BIM could promote smart city development? So maybe we can have Nora to answer for us, maybe?
Yeah, okay. So thank you for the question. And I think we all know that the government is actually sparing no effort in promoting the smart city development. And then the emergence of actually the BIM and GIS integration will bring a whole new approach to the construction and planning industry. So we find that the introducing some geospatial services into the infrastructure design and actually the construction will give us safer and much smarter buildings and transportation. Like if you merge the BIM and GIS data, it will give more efficient workflows and also some more consistent data. So we think that this means that the design companies and the construction companies can actually view the newly built buildings in the actual context of the surrounding environment. That gives a much safer and more comprehensive planning and design process to the construction. And it also some kind of eliminates the data redundancy and actually can move data between different stages of the construction process seamlessly. So I think that after all, I think the BIM and GIS integration actually plays a very indispensable role in smart city development. Thank you.
Yeah, thank you, Nora. And especially, I know that recently the Lands Department have opened all the map APIs for free to use. And also the Geospatial Lab have already launched. So because of the CSDI, I think most of us will be benefit, and especially in the GIS and BIM integration. Okay, so let's see the second question we got. What are the major difficulties you encountered in integrating these two technologies? I believe it's GIS and BIM, and for site planning and building design. So maybe we can have Daniel to answer for us.
Okay, thank you for the question. So, in my opinion, one major obstacle would be the data compatibility, because there are two separate or individual platforms, and each platform they upgrade or update separately. So the problem is that the interoperability is limited. by the versions of the both platforms. For example, the Revit from Autodesk and also Arcgis Pro from Esri. So in our case, the problem is that the Revit version is the newest version, while the Arcgis Pro is a more a traditional version. So there are some incompatibility. So this limits our progress, and we need to have extra efforts in order to advance into a more better way to do so, to do the projects. And we solved it by using the IFC intermediate step to convert the model twice in order to save the project in a compatible version for the later on the Arcgis environment conversion integration process. Okay, so I think this one is a major obstacle because it requires more effort to do so, and also there are some technical issues which is derived from the IFC intermediate step. For example, there are some bugs or some missing information. So, but I think in the future there will be more improved, and a more smooth integration will be conducted. Yeah.
Thank you, Danny. And especially at Esri and Autodesk, we have signed agreement in several years ago for the advancement and integration. So I'm sure there will be more integrated platforms, and actually our Arcgis Pro can also direct with Revit. So yeah, maybe there will be more development coming on, and please get excited about it. So let's see our third question. So the question is about BIM model to GIS platform. So the person who asked said, as my previous experience, the model visualization quality is not like the team shown in the BIM slide 2 to 3. And any model conversion deform problems by using BIM and GIS platform, and allow full model content convert to GIS platform. Any tricks on that? Maybe Daniel, can you also answer this question for us, please?
Okay, thank you. So yes, indeed, there are some differences between the BIM visualization and also in the Arcgis environment, because there are two different things. One is a BIM model plus a rendered engine to render a still image, while another would be the GIS initial rendering. So, but it's actually fully customizable in Arcgis Pro, which you can color change the colors of the walls, the components, and so on. So it's actually fully customizable. And I think, and another problem is the thing that I mentioned just now, the data incompatibility, which after the IFC intermediate step, there are some bugs. And for example, the colors may not be the same, or so on. So there are something that we need to improve on, but we want to record the whole process in order to see what the current situation is. And one more thing would be there is actually some simplification of the model before we import it into the Arcgis environment, because it requires great computing power. So if you have a good computer, and also you have the right compatible version of both platforms, I think it's actually perfectly fine to import the full model content into GIS platform directly without any other intermediate steps. And also there will be far more accurate than ones that we did. So I think, yeah, so once you have these two criteria, then everything will be fine.
Okay, thank you, Daniel, for the tricks for our audience. So let's see the next question. Do you think you could perform similar tasks? I think the person who asked should mean site planning and building design without integrating these two technologies. So it's GIS and BIM. So maybe Calvin can answer this question for us.
Sure. Thank you for the questions. And I think the answers can be divided to yes and no, because for the no part, you can actually you cannot do the visualization part efficiently and effectively if you do not integrate the BIM model into the GIS software, because without the 3D model, we cannot conduct 3D analysis, such as the noise level analysis, such as the shadow analysis, so on and so forth. So what you see in the CIM analysis are actually required the 3D models provided by both lens department and also the model made by ourselves to conduct the analysis. So for this part, the answer is no. But of course, there are some 2D analysis which have been showcased by Kelly and Nora in the first part of the presentations. So without the BIM model, we can still conduct, for example, the surface area analysis or the travel time analysis, etc. So, but of course, we think that with the integration of BIM and GIS all together, the visualizations of the results must be a lot better than plain without the model. So I think for the analysis part, the answers can be yes and no. But at the same time, we also showcase the website made by ourselves. So it actually combines with a lot more technology, including Arcgis Online, as well as other programming languages. So for this part, we cannot and we must not complete the task without integrating the technology. So, so both BIM and GIS are quite important to facilitate the town planning process, I think, in the future as well.
Thank you, Kelvin, for your explanation. So let's see, we have another question. Your team had conducted several spatial analysis. Is there any particular spatial analysis that you find it most challenging to conduct, and why? Maybe we can have Kelly to answer this question for us.
Thank you. First of all, thank you very much for the question. This is really interesting, but in terms of difficulty, or the actual analysis on ArcGIS, since most of the spatial analysis we're doing are using the same process or the same method. So there was not really a big issue, but I think the most challenging or the most tedious part is that you have to input or find your locations or to do your analysis on. So when we're doing this project, we could not access any data on the API by the lens department yet. So we have to look for our own information and the locations on like GeoInfo map, on Google Map, even for example, the number of bus stops, as you can see during our presentation, there were a lot of them. So we have to go through different bus company application to look for the locations, just to make sure that the data we're inputting into the map is accurate. So I think that one of the most challenging part would be inputting the data. Otherwise, I think with the easy instructions or the easy usage of ArcGIS, I think it's a pretty good tool, and it is not especially difficult to do any analysis.
Wow, thank you, Kelly. So maybe the lens department have already opened the API, and we are looking forward to your next project presentation for our next webinar, maybe. Okay, so here is one more question. What is the format of the BIM data? Is it a single file with all the floor instead of using the reference files for combining the entire building? Maybe you can have Daniel to answer this question for us.
Sure. Thank you for the question. Because we're using Revit for doing the BIM model. So the BIM data is indeed a single file with all floors, because we Revit dimensions and also everything within the Revit environment. So we're not using
Okay, maybe the connection has some problem, and thank you, Daniel, for trying to answer this question for us. But actually, we're also running out of time. So for all the unanswered questions, we will give you email feedback by sending you the email. So let's move to the next section. So if you're working in the AEC industry and interested in our Arcgis product, so don't forget to get up to 70% reimbursement from the CITF funding. In addition, we now offer a training course on BIM and GIS integration. You can get full reimbursement after successful completion of the 6-hour course, which will be held in the same day. In other words, you don't have to pay a cent for the course fee. So this is our last polling question for today. Would you like us to contact you to discuss about our Arcgis technology and training available under the CITF? So we have yes or no. Let's have 10 seconds. Okay, so most of you answer yes, and you will be contacted by our GIS analyst very soon. Thank you for your feedback. And our next event will be our Young Scholar Award presentation ceremony. It will be held on 20th of July in hybrid mode. The top 3 winners, including speaker of today, Daniel, are going to share the winning story map. The story map topics are related to smart city. They are save people from the concrete barriers, exploring the transit-oriented development level of Hong Kong, and plan smart, build smart. Let's stay tuned. And don't forget to subscribe to our YouTube dedicated page, SB China Hong Kong, to get the latest updates and rewatches of our videos, including the 5 minutes lunch GIS takeaway and webinar series. You will be able to find today's webinar recording in this YouTube page very soon. To stay tuned and get the latest updates on GIS news, please like and subscribe to our Facebook page, Instagram, YouTube, and LinkedIn. For any inquiries, please contact us by phone or email at event@sbchina.hk. You may also scan the QR code to visit our company website for more product news and details. Thank you very much, and we wish to see you soon in our next webinar or hybrid event. See ya!